Sliding window is the close cousin of two-pointers, and it's the trick behind a huge number of array and string problems. Today we'll cover the core idea, the two flavors, fixed size and variable size, three classic problems they solve, and when reaching for a sliding window is the right move. Here's the insight. When a brute force recomputes a sum or a count for every subarray, it throws away work it already did. A sliding window keeps a running answer and updates it as the window moves. Add the element entering on the right, remove the element leaving on the left. Fixed windows keep a constant size. Variable windows grow and shrink based on a condition. Either way, one pass, O of n. Picture a window sitting over a few cells of the array. To slide it one step right, you don't re-add everything inside, you add the new cell on the right and subtract the old cell on the left. That's the whole trick. Each slide is constant work, so sweeping the entire array is linear instead of quadratic. Start with a fixed window, the maximum sum of any k consecutive elements. Sum the first k to seed the window. Then slide. For each new element, add it and subtract the element k positions back. Track the best sum as you go. No nested loop, no recomputation, just one clean pass in O of n time. Now a variable window, the longest substring with no repeating characters. The right pointer expands the window one character at a time. The moment we see a duplicate, the left pointer jumps forward past the previous copy. A dictionary remembers the last index of each character. The window is always valid, and the answer is its biggest size. One more variable window, this time shrinking, the smallest subarray whose sum reaches a target. Expand on the right, adding to the running total. The instant the total is big enough, shrink from the left as far as you can while staying valid, recording the smallest length. Expand to satisfy, shrink to optimize, the heartbeat of variable windows. When should you reach for a sliding window? When the problem asks about contiguous subarrays or substrings. When you want the best, longest, or shortest range that satisfies some rule. When a brute force would recompute overlapping work for every range. If the elements aren't contiguous or order doesn't matter, a window is the wrong tool. Look at hashing or sorting instead. Sliding window turns a whole class of quadratic problems into single linear passes just by refusing to recompute what you already know. Next up, we shift from clever passes to a deeper idea, dynamic programming, where we close the loop with recursion and never solve the same subproblem twice.